The viscosity of liquids also comes from intermolecular forces and how strong their IMFs are in their liquid state. And the stronger the IMF, the more viscous or the more thick the liquid is, versus so they're more stuck together versus something that has very weak IMFs and they can just slide past each other and be really thin at our level. They seem very thin. So I have a good video of a bunch of stuff getting thrown into a beaker showing different types of viscosities. If it splatters a bunch, it means it's a lot less viscous. And if it doesn't splatter as much, it means that the intermolecular forces are really keeping it all together and in form, and it's not splattering as much, or big fat globs are coming out, which is cool to watch. And then I have an awesome video about the most viscous liquid out there. It's actually pitch and tar, which makes up our roads, which is kind of crazy to think that's a liquid. But basically, they take the stuff that makes up our roads, which is these polycyclic aromatic compounds, which just means a huge bunch of rings. If you look in the bottom right corner, you can see all these rings, and that's basically what makes up tar. And they have super strong intermolecular forces, really strong London dispersion forces going on there. There's just so many places for interaction. And they stick together really well, like almost like a solid. But the thing is, they put it in a funnel and they realize that it's after, I think, every 10 years a drop drips. So it is a fluid-like substance, even though it's mostly not really moving that much because the IMFs are so strong. It is a fluid, which is really cool. And the Veritasium video goes really into good detail about that too, and talks about what liquids are and is glass a liquid, and he does a really great job, so I highly recommend those videos too. Awesome. So viscosity is just from IMFs.